Scientific notation takes a standard form number and puts it into two parts, a mantissa or number that is between 1 and a number less than 10, so it's a single digit in the ones column, and a multiple of some power of 10, and that power is called the characteristic. So in this case, if you look at the particular scientific notation, we have 2.11 or 2 and 1100ths times 10 to the 5th. And we're going to find that if we were to multiply by 10 to the 5th power, we are going to move the decimal point a total of 5 places. 2 of the places jump the ones that are part of the mantissa, and then in order to get a total of 5, I would have to add 3 zeros. Now, the second scientific notation is 3.7, but it is a negative characteristic. Therefore, I'm going in a smaller direction or going to the left. So the decimal point will jump the 3, and then I will have to add 1, 2, 3 more zeros to the 1 that I already jumped for a total of 4 place moves, and the decimal point will be here, and it will be 0.00378 on the decimal side. All right, those are the two manipulations for scientific notation, and most everybody's doing very well on that. All right, let's look at two more problems. Here is a scientific notation that is going to raise this number, the mantissa, to the 5th power. It's going to move the decimal point 5 places. So if you'll notice, I have 3 places here, 3 numbers that are being jumped as the decimal point gets to the end of the mantissa, and then I'm going to have to add 2 more zeros so that I can jump 2 more times to get the decimal point to the end for a total of a power of 5 change from the mantissa to the standard form. Now, in the second one, we are going in the negative direction. So I'm going to take the decimal point, I'm going to jump the 8, that's 1 place, and then I'm going to have 2 more zeros to be able to get the number into standard form. All right, most everybody's doing well on that. This is where we run into problems. All right, if I'm going to multiply two scientific notation problems, the first thing I can do is I can bring the two mantissa together, and I can multiply 7.1 times 4, and then I'm going to also bring the two powers together, and I'm going to have 10 to the 3rd times 10 to the 9th. Now, this first part in the numbers will end up with 28.4, and when I add the exponents, I get 10 to the 12th power. The problem for this is that the mantissa is no longer in scientific notation format. It's too big. So therefore, I have to bring the 28 down 1 place to make it smaller, and therefore I'm going to have to take the 12, 10 to the 12th power, and I'm going to have to take it up 1 place so that I don't change the overall value, and the new scientific notation will be 2.84 times 10 to the 13th. This adjustment is something that you have to acknowledge in order to make the answer stay in scientific notation. All right, so now let's look at a division problem. All right, in this case, I'm going to take the mantissa, and I'm going to take 2.4 and divide it by 6, and then I'm going to take 10 to the 3rd power and divide it by 10 to the 7th power. Now, when you take 6 into 24, you get 4, so 6 into 2.4 will be 0.4. And then when I subtract 3, subtract 7, because I'm dividing, I will get 10 to the negative 4 power. Again, the mantissa is not in standard scientific notation. And so I have to make it go 1 larger, and therefore I have to make the -4 go down 1, and my new number will be 4.0 times 10 to the -5. All right, so when we look at this, you should begin to see that you are going to take this number of the mantissa and multiply it by 2, and then we're going to take these two powers and add the exponents together. So when I do that, I'm going to end up with 16.62 times 10 to the -5. However, the 16 is not in scientific notation, so therefore I go down one place here and up one place on the power, so that I have 1.662 times 10 to the -4, which is proper scientific notation. When we do that with division, I'm going to take 6.8 divided by 8.5, and that you can do in your calculator. And then I'm going to have 10 to the 4th minus 4 minus 7, which will be 0.8 times 10 to the -3. The mantissa here is too small, so I have to take it up 1. When I take it up 1, then I take the exponent down 1, and I'll have 8 times 10 to the -4. All right, so let's try one more group. When I multiply the mantissa, I'm going to multiply 5.3 times 4.7, and when I multiply the powers, I'm going to take 8 and add a -3. So therefore, I have 24.91 times 10 to the 5th. The 24 is too large, so I take it down and take the 5 up to 6, and now I have a correct scientific notation. All right, and for division, when we take these two numbers and divide them, we're going to get 4.5 or 0.45 times 10 to the 3rd. All right, this number for the mantissa is too small, so it goes up 1, and the power comes down 1, and I'll have 4.5 times 10 to the 2nd. All right, those are the scientific notation problems that you need to be able to do well. And some of it is just remembering that after you do the multiplying or dividing, you still have one more step if the numbers are not in proper form as far as the mantissa is concerned. Okay, so if you'll do these two worksheets, start with the practice notation first, because that just reminds you what you're supposed to be doing in creating scientific notation, and then you have basically multiplying, and that is what I just got done on these last two slides. And so you should do this well, and hopefully you're going to ace this part of the test. All right, thank you.